So you can try and open it then in R. Just a reminder as to how you do that, but now you should be able to load data sets in your So usually, again, I set a working directory, and then it's there. And then you would require the Haven package to load the SPSS data file, as you've done in some of the assignments that you've seen in some of the first lectures. So don't copy the first bit because that's relating to my Dropbox. Yes.
How, you know, like how obviously you get on a normal actual thing, like where it is. How do you do this on here? So like I can get like the link to it. Do you know what I mean?
So you don't need to have the hyperlink. So you just need to put it in the working directory during lines.
Yeah. I just thought I needed a little bit where you put Dropbox teaching and press that bit. How do you get that bit?
How do you do that?
Yeah, I don't know.
So it's just copying that line. So it's
I can't get it in here.
No. So you open our studio.
Yeah.
So you can find the location. So this is the actual location.
Oh, right, yeah.
So it's in downloads.
Yeah. So if I just do all that, so copy that and then put the name of it.
Well, you have to use the slash and thing. So the tilde is where it abbreviates. So my full thing would be users Thomas Pollitt Dropbox teaching things. So but otherwise you just don't as we've done for the other things, you can just put it in there.
Anything I'll be saying about the HTML.
So then you should see if you click right click and go back. Do you have to do the So
we are
changing
into this in so
no, just right click. Save and hopefully if you save and change the extension to the and then it might actually try to. So it could be that your computer has never worked with a WhatsApp file and doesn't know what it is. So double click and you should be able to
if you definitely not worked, does it? Maybe that's just
The reoccurrences, isn't it?
Yeah.
Thomas,
Yes.
it's not working.
What's not working?
It just won't.
Can you put it further down?
I'll try to save
So
it,
I
but
can
not
write
it won't save as
Oh,
HTML.
no.
Yeah, so you're having the same as
So you do like bracket, and then
yeah, it
it
won't
shows
load
here,
an
and then you
HTML
can just
file.
copy that.
So, but you should be, if you try for your assignments, you should be able to.
Yeah, I'll try and do it this way. You need to have a look at it. Same hole.
So, where it's stored, try to change it as a, like, okay, so it's in the masters.
Yeah, it'll be in my
Or do you have, is that a skim or like, it's not packaged, is it just like part of the
Okay.
No, but I don't think that is. I think that's
We
for
try to
frequency
change that
and
to
distance.
WhatsApp. You want to change it? And if you now try to open it again, perhaps it will work. Otherwise, I'll post a copy of the data file also on online. That doesn't work. So it could be that some things are specific as to what your thing is locked down. Okay. I'll see if I can quickly put it on Blackboard.
If you, hang on, if you just.
It's not saving the rest. If I'd have done this now, streams.
Did you want it to save it in documents?
You don't know
And then.
So if uploaded to Blackboard, so people who can't access it, it could be that the computer is locked down, that you can't do it, but in principle you should be able to just click a link and be able to download a file. So I don't know what's going on, where it could be Internet Explorer, which doesn't like .sat files, but so it's uploaded now from Blackboard in case you need it, and you should be able to put it in your folder. I'm just going to carry along for now, because otherwise we'll go too slow. Okay. So for the people who are able to view the data, we have data from 3 groups: Asians International, Asian Americans, and European Americans, who completed a personality measure, which is the NEO-PI, or something you might have come across as well. And you can read more about the actual paper by clicking that link. And so this is how you would read the data into R. And then you can use the skim thing. So if you managed to install skim R before, we can use that to skim through the data and find out some more information about it. We won't have printed the entire lots, but we can see A, agreeableness, C, conscientiousness, E, extroversion, N, neuroticism, O, openness to experience. We have an ID variable, and then we have a variable denoting which group they're part of. Yeah?
Do you know what skim R is? That the package? Because when I'm teaching it, it's just not coming up.
Yes, because as we will go back to the slides, SkimR you would have to install via link, and it's not listed in the packages. So when you go back to the slides, you saw that I installed it from a link, and so it will not come up in those packages. It's not something you need, but I think it's quite handy for some of the things. So you can do all the assignments without SkimR, but it's quite handy because it sort of gives you an overview of like which cases are complete. It gives you the mean, standard deviation, minimum, maximum straight away in like in a data frame. Yeah. So you will have to use some type of install from GitHub type of command in order to get it if you want it. But again, you don't necessarily need it. Okay. There's 2 missings in the data set, and so by now we should be able to remove missings. And to that we use our favorite package, which is dplyr. And the missings are not a number in this case, so you need a different type of command, which you would also remember from the first thing. So we have data, no miss, filter, data, group is, and then it's not a number. And if you do that, we'll print the labels, and then we can use print labels to find out what the codes are for European Americans, Asian internationals, and Asian Americans. There could be other ways in which you could filter out the missing. So you could use the ID variable because they also don't have IDs. So there's 2 cases which don't have a label, and so it's good to filter them out straight away because we won't be able to use them. So what has happened here is you have data, so you don't yeah, so you need to, you've called it, it was actually personnel. I've called the line which says data is exactly. So if you go back, you can see that I've used data, weak SPSS. I didn't install it. Yeah, you load it that way. So when I put the that to try and name it. But it has to be in that folder now, so it has to be in your address folder. So if it's not in your address folder, you need Haven to run it. So you need to have a line which is require Haven. Because Haven is the thing which loads SPSS data. Yes. Yeah, so installing it is not sufficient. You also have to call it and then we'll do your actual bidding. So because I've said it's missing, can what is this way? I don't need to name data. Well, I think it's best if you do it that way. So we need read underscore. The name. I need to add the quotation marks. Yes.
N-A-N, not just N-A.
Because it's not a number, and so there are some things in there which are not a number, and so N-A-N. So if you go back to the first thing where we discussed all the commands, N-A-N is not a number, N-A is missing. And so if you look closely, there will be some, if I'm not mistaken, there will be some things in there, but they're not a number. So that's why we use this. Alternatively, you can use the ID command, but I just wanted to show you can also use NAN, not a number, to do that. Yes.
some perfect vectors, and you can't download it.
What has happened is you've not loaded deep.
It's so annoying.
Yeah, install it, but you haven't. So you can see my code.
Yeah.
Yeah, it's worked now. Okay. Okay. Everybody sort of with me. So don't follow along the entire time. Now I'm just going to go through things until we get to the exercise.
It's best just to install dplyr on everything you do, even if you don't use it.
Yeah, so dplyr is dplyr is a very common package, and so you can also remove missings in a different way.
Yeah.
But I've shown you dplyr because I think it's quite easy. You can chain commands together via the pipe, so especially if you have to do longer things. I would recommend that you use dplyr. So that's why I show it to you, because it will save you some time, because you can put commands together after one another by using a pipe, as I showed you last time. And so again, so if you load, it's not sufficient to install a package. You have to make it available to R. So you have to always use require or library to do that. I've just found out that I put a slide in the wrong position, but I'll correct that next time. So we're going to test whether openness to experience differs between these three cultural groups. And that's what we want to find out. And then you're, as part of the exercise, are going to do other groups as part of the in-class exercise and other personality traits. So this slide should come later, but in order to check these type of things, I know it's actually correct. So non-independent observations, if they did it correctly, this is something we can't really test unless you want to do autocorrelation type of plots, but they're quite difficult. But we're sort of assuming that they done it in a correct way, and that every single person is sampled individually, and they didn't all collect one in one class and the other one in the other class. The interval is dependent, so check. So that's it's an openness to experience score, so we're good for those assumptions. Now, normality, as you might know, we can do visual inspection, so we can look at the plot and sort of see, does it sort of look normal? You should sort of remember what a normal plot looks like, so it should be this type of nice histogram, and we need to do that. Ideally, you can do it overall, but ideally you would do that for every single group to see if they have this nice bell curve going on, yeah? And then the other one is homogeneity variance, so those are the assumptions we have to check. And sometimes people first run the test and then check later, and we'll come to that as well, but here we're going to try and check them first before we do the actual analysis. So, this is not the most beautiful plots, and I've shown you how to make beautiful plots, but for our intermittent purposes, we just want to find out if it sort of looks like a histogram. So, you recall ggplot, you can use plot, and you can use the code from last time to make a pretty looking histogram like this, and then I did change the color so it's black and white, but you can then make it even more beautiful by changing the O to openness and experience, changing the axes, changing the background. But for now, we just wanted to find out if it's more or less normally distributed. So what do you guys think based on the plot? Sort of looks okay, no? We would have hoped perhaps for a bigger peak here in the middle, but it's not entirely bimodal. It's sort of what we would hope for a normally distributed thing. So most people would actually look just at the overall plot and then assume that for subgroups it's sort of okay as well. But sometimes you also want to look for the subgroups, and you've known how to make separate plots, but you can also panel them, and then you can do this by different groups. We use the facet wrap command or the facet grid command in order to do that from the last week, which you will have used perhaps also in your assignments to make a paneled chart. So there are different ways of doing that. But you can make separate graphs and panel them together in a chart, or you can make a paneled chart like this. And you can sort of see, perhaps with group number 2, it's somewhat less normal, but group number 0 we're quite happy, and group number 1 we're quite happy as well. And just to remind us, 0 is, if I'm not mistaken, the European Americans, 1 is the Asian internationals, and 2 is the Asian Americans. Yeah. So perhaps for the Asian Americans, the distribution is not all that pretty, but by and large, I would say that I'm fairly happy with that. Would you do the same, or would you say Okay. So what do you think? For more or less okay. The other thing to remember is that for larger groups, deviations from normality are fairly robust. So you might have come across also year one the central limit theorem. Does that ring a bell? Does anybody care? I saw you nodding, so yeah. Okay, so basically, as sort of illustrated in this graph, the more and more data points we have, the more and more our statistics will become robust to deviations from normality. And that's because the test statistic will become more and more robust. The larger the sample reaches the population becomes closer to a larger sample. So I won't go into derivation, but it has to do with the law of large numbers and all sorts of other things. But basically, you will get slighter and slighter deviations from normality as your group size increases. And given some people say the cutoff is around 30, and so your statistics become more and more robust after around 30 total, or 30 per cell if you're quite conservative. But we have, if not mistaken, 305. So even if it's slightly violated in that group, we're going to hope that the central limit theorem helps us. Yeah? So other approaches you might have come across, some of the formal tests to test whether this distribution is normal. You might have come across a Shapiro-Willis test, which is a test to see if it's normal. And so if it's not significant, then you retain the null hypothesis, and that it's not significantly different from normal distribution. And this is how you would do it. So here I made different subsets. So again, using filter command from dplyr. I didn't require dplyr again because it's loaded in my thing, but if you have lots of space between chunks, load packages again, because otherwise R forgets that it has to use the packages. And so I use the filter commands to create separate groups, yeah? And then I've just given you one example to show how you would do it. And then it will print something. And we want this test not to be significant in this case. Yeah? Everybody with me going too fast? So there's we'll build in some time so you can run through some things later, but you can also review the slides and do it later. But there's no need to copy every single line and see if you can get it to run on your system. Yeah.
Who are all these people? Smirnoffs and
so they're all statisticians. So if you're very lucky, you get a test named after you.
Sounds like Franz of Volcano close.
Yeah. So if you're very lucky, then so we have Pearson for the Pearson correlation test, which is named after Carl Pearson. We have Gaussian distribution named after Gauss, and all sorts of other things. So they're not named after. There's no branding, so it's not vodka based or other things. So the Kolmogorov-Smirnov test is easily significant with large samples. So that's why I would recommend mostly that you rely on visual inspection. So mostly you would look at their charts and make your decision that way rather than using the tests. So this is how you would do a Kolmogorov-Smirnov test. And again, I've just done it for one. I've just done it for the first group, which are the Europeans. And the p-norm in this case points to the fact that we're testing against the normal distribution. So R has some built-in functions where you can also test against other different distributions with a Kolmogorov-Smirnov tests, and the p-norm just tells it to use p-values from a normal distribution to test against. And this is, in this case, you get a very different result, and it's highly significant. So that would point you that there's lots of problems with normality, but you've seen the chart, and it's actually not that bad. And the reason it is because as sample size increases, this test will become very easily significant. So there will be lots of things where you think it is going to be problematic with this type of test, but actually if you look at the data, it's not all that bad. So in principle, I have to tell you about it because your supervisors might want you to run it, but be aware. Yeah. So recommendation is to check normality visually, and you have to think back to the data source, which we saw last thing. So the same type of test statistic can mean very different things depending on what you look for. So look at histograms, not Instagram. Look at histograms to find out what the distributions are like. So that was the check for normality. And ideally, I've just I've just given you one example. Some people stop at the overall tests, but ideally you would test it for all the subgroups and see that all the groups have a normal distribution in their dependent variable. There's a variety of other options that I've only told you about: Shapiro-Wilk and Kolmar-Smirnov. If you want to find out more, these are all sorts of other tests which you can run for normality. So Anderson-Darling test, Kramer-Hormesis test, Rederford test with correction. So that's a correction for the Kolmar-Smirnov. Shapiro-Francia test, the Yarka-Barrett test. There's all sorts of other tests which you could run to check if your data is normal. But I would recommend that you stick to looking at charts. Yeah. Homogeneity of variance. So that's the other assumption. You might recall we have to check. You might have come across Bartlett's test of homogeneity of variance, but that assumes normality. So most of you will have actually heard of Levine's test because that doesn't make this normal distribution. But if it's significant as Bartlett test, it could point to deviation in normality rather than deviation in homogeneity of variance. But it tends to have better power if your data is actually normally distributed. So if your data looks more or less like it's normal, then you should use Bartlett's test. If it's all over the place, then you might want to use Levine's test because it's more conservative. Yeah. So this is, again, most of the things, it's just the name of a test with a dot in between, and that's how you run it. And so the O is for the openness to experience. The tilde is so usually this is the dependent variable. This is the thing which is being applied to, and this is the independent variable. And usually you also have to tell it where you've stored the data. So most of the commands you come across in R will have this type of structure, and you might have also seen it in previous things when you were doing t-tests or when you were doing or when you're making your charts. So that's the type of structure you will usually have. So first, the dependent variable tilde independent variable. So y tilde x. Yeah? And so in this case, good news, again, this is a test you don't want to be significant because it means you can keep the assumption of homogeneity variance. So that's good news for us, that there is no violation. Yeah, so, and it prints data all by a group. It gives you a statistic, it gives you degrees of freedom, and some p-value. Yeah? Perhaps much more familiar with Levine's tests. Yeah, so several of you might have run that for your projects, for your bachelor projects. And so CAR is the package which does the tests. I've again loaded dplyr to make sure it doesn't forget it has to use dplyr. We have to make something into a factor because otherwise CAR is going to struggle. So you remember the different categories of variables. And so if it's coded 0, 1, 2, R will see it as numbers, and we have to tell it it's a factor. So that's how we do it. Just with the asFactor command from dplyr, we turn it into a factor. Yeah. And then command here is not with a dot, but it's Levine test. So again, R is quite picky in terms of spelling. So if you put Levine.test, it might not run. And that might be because there's somebody else who made a package which does a Levine's test in a very different way. And that's why everything has different specific names. But this again is the same type of command, but now I've used group fact rather than group and the data. And again, what we found with Bartlett's test is upheld with the Levine's test. We have the same conclusion. There's no violation of the homogeneity variance. So that's good news. So we can proceed, right? So outcome of assumptions. So you would write that up in your report as well. So we're quite happy. We're high-fiving a million angels because you could keep our assumptions, which doesn't always happen. So normally in your report would then write visual inspection suggested that the distribution of dependent variable is close to normal. Yeah. And if you've done that for all the subsets, you would say for each condition or for each subset. And then a Levine's test suggests that the assumption of homogeneity of variance is not violated. You put in the f-tests, the degrees of freedom, the value of the f-tests, and the p-value. So to go back, that corresponds to this value, and that value. Yeah. So that's how you write up your Levine's test in actual report. Again, something which you will have done for your undergraduate thesis or for your statistics assignments, I presume. So that's good news. We can move on to the actual ANOVA. So as an aside, if you were really, really gritty, you would mention something about that deviation we found in the second group, and you would mention the shape of the curve that is different from a normal distribution. Yeah. So if you're worried about your assignments, and some of you would have written there is a deviation normality in the second group, I would have also considered that correct. So, and in your assignments, I would just have both correct. And just to remind you, you can have curves which are mesokurtic, leptokurtic, or platykurtic. So it's basically what it looks like in terms of how the peak looks like. And then you can have things which are right skewed or left skewed in terms of deviation from normality. So this is an example of a right skewed distribution, and this is an example of a left skewed distribution. So when you have this type of shape, you have some fancy Greek terms to find where the peak is, and you have some fancy cases. So in this case, you would say that there would be platykurtosis in the Asian American group because it's squatted down. And for a normal distribution, it would be like this. Yeah. But again, in your assignments, if you would have said it's all normal, that would have been fine. Yeah. So some of the things is just that there is no real cutoff, and different people will reach different conclusions based on the same thing. Of course, if you would have said it's completely violated and we can't run an ANOVA, then we would have had a difference of opinion. Yeah. So try it yourself now, and then we're going to have a small break. So test the assumption. So I've done it for openness to experience. Now do it for extroversion, and again group as the independent variable. And you should work. You have all the code actually in the slides, so you should be able to work your way through that. It's just changing the O to E actually, which would run most of it. But again, you have to install bplyr, and you have to do something. So check the normality assumption and check the homogeneity of variance assumption, because the other ones we've already checked.